Good evening, everyone. My name is Shane Singleton. I am an electrical engineer, a junior, and this last year I had the opportunity to take a class with Dr. Stephen Dyer and Frederick Burrack called Signals, Systems, and Music. And I can tell you, enrollment time's coming up, and as an engineer you have three options. One, a hard class, two, a hard class, or three, a general elective, which means something close to level 100. So this class doesn't fit into any of those, but Dr. Dyer will tell you more about that. So cool, but here he comes right now. Dr. Dyer.
To an excerpt of a composition that was done last semester here at K-State. In fact, there were several compositions done. They were done in partnerships. Each partnership had one music major and either one or two engineers. You'll get to hear some of the other compositions splattered amongst the rest of this evening tonight. And I hope that you enjoy them. They were done in a course called Signal Systems and Music, and the whole notion of that course was to bring people together, people who were different from one another, or at least in different disciplines, music majors in this case, and engineers. We wanted to put them in an environment that was an active environment where they got to learn some concepts of the other discipline, but at the same time be able to do something with those concepts and work together. There are two words that I'd like you to take away from what Fred and I have to say tonight. One of them is creativity and the other is connections, and that's what we wanted to deal with in this particular course. We started out with concepts. No matter what your endeavor is, there are some fundamentals if you're a practitioner of a particular discipline. We might talk about pitch, we might talk about loudness or timbre if we were interested in music. If we were a physicist or an engineer, there might be some simple concepts such as frequency or amplitude or spectral density. Turns out that those two sets of concepts or quantities are actually very tightly related, although they're not exactly the same. And those are some of the things that we wanted to get across to the students in this class, these two sets of students from two different disciplines. That's one of the things we wanted to do, but we also wanted to give them a chance to be creative together. The creative processes end up being important to whatever discipline we decide that we're interested in. To music, composition is a very important creative act. Design is the principal creative act for an engineer, and it turns out that those two processes are quite a bit the same. So we wanted to provide an environment for students, number one, to learn some concepts about another discipline. We hoped that the environment would, in fact, pique their curiosity so that they could walk a little bit further into the vast applicability, the breadth of applicability of these particular concepts. And once they got that accomplished, we wanted them to experience the challenge of trying to work with someone who was different or had a different background from themselves. And one of the first problems there is when you want to work with someone who's of a different discipline is to develop some sort of communication. And to communicate when you don't even have the same language is sort of tough, and this is what the students got to involve themselves with in this particular course. Once you can communicate a bit, with one another. Then we wanted them to actually create something together, to go through the creative act, and in fact, that's what happened with these musical compositions. With all of this, the intent was that people would become appreciative of disciplines that were other than their own chosen disciplines, that appreciation would come through a little bit of understanding about that other discipline. Speaking for engineers, there is a lot of art involved with engineering. Unfortunately, it's not particularly apparent as a student goes throughout her undergraduate education. Gordon McKenzie talks about this particular set of Siamese twins, these twins that are connected together all along one side. They're inseparable. There is the brother on the left and the sister on the right. It's this set of brain twins that have their entire lives together as their destiny. And again, from the engineer's perspective, our hope was that the students would get a chance to look back on the concepts that they had learned and move past the left brain part of their education and actually engage with the right twin just a little bit to have some sort of rational experience in all of this.
When you talk a little bit about what you want to get your students to get out of maybe something in your course, the learning that is to occur, I think all of you would say that you want your students to get beyond just knowledge attainment, but you want them to take that knowledge and apply it to particular situations. And even beyond that, you want the students to apply that knowledge in some problem solving, in some creative decision making, maybe possibly create something new, or to solve some problem. When I asked the students what they wanted to get out of this course when they first started in the course, they said two things. They wanted to learn how to communicate with someone outside of their discipline, someone who, this came from the words of the students, someone who thinks radically different than they do. And they also wanted to learn how to collaborate together with a different discipline, because all of the students in the class said that this is something that was important to them. They knew it was going to be essential beyond their discipline, and they said that their current curriculum, at the point that they hadn't experienced that this was intentionally taught or designed within their courses. So that's what they wanted to get out of it. At the end of the course, we asked them what you did learn out of it. In addition to those two things, a third thing popped up, and that was a new conception of what the creative process was. The engineers talked about a new discovery or an understanding of the creative process that lies somewhere out of a linear progression, all that leads to one right answer. And in the process of these projects together, they realized that the creative solution quite often lies outside of that linear process. So what they wanted to do at this point is take what they learned from this course and go into their engineering projects with a new perception, a new direction on, instead of following the rules and doing it the most efficient, effective way, maybe the answer lies somewhere outside of that. And the musicians, on the contrary, what they learned is that in the creative process, the importance of being able to listen to someone else's perceptions and put that together and see how that generates into something new. Because what the other person contributes is something that they couldn't be able to create on their own because it wasn't part of their perception. What can we learn from this? Sometimes although we have the greatest intentions of moving our students through this effective and efficient process of learning, sometimes we forget to give them the opportunities to step outside of these boundary lines and outside of this most efficient, effective way to learn, to explore and experience creativity, and sometimes that's where creativity actually lies. Now let's hear what the students say about their learning.
An engineer is a process-based thinker. Everything, we have a start point, we take our information, we reach an end point.
We're taught as engineers to look at something, dissect it, find a better way to do it, and if something's already working pretty well, you will have to get pretty creative in the way that you're looking at something, or music, but I think there are a lot of similarities.
How how to communicate ideas to someone else, especially those abstract and musical ideas. Definitely like in industry, working with clients, I think that's a really important skill to have. It's really important to learn how to communicate in those ways.
Take a wider view of a problem, I think, is what I learned. To understand other people and to be able to grow, the way I see the world. The creative process was really cool just because just to kind of watch him, that creative process was really interesting.
I definitely learned that it doesn't just happen. You've got to limit yourself, but at the same time, you've got to allow yourself to think, oh, this would be cool, that would be cool, which involves doing it in more than one try, stepping back and thinking and going back to it again.
Definitely one of those things where it's different because there's not like a, you're done. There's not like a right answer to it.